Well, it's been a while since we've been here, but we are back. Another segment of Learning with Lindsey. Lindsey, what do you got for us today? I'm assuming you're not talking about Superman's cape here.
No, we are talking about convective available potential energy. We call it CAPE for short because obviously that's a mouthful.
Sure.
So what this measures is actually just atmospheric instability and the amount of energy available to kind of fire up a thunderstorm. So if we have a lot of CAPE, and I'm sure you've heard me talk about it, you've heard Doug Hetty talk about it, if you have a lot of CAPE, that is a good ingredient for severe weather. So we can go to the next one.
So how do we measure CAPE? Because CAPE, like you were saying, is the amount of energy that we kind of have. Right.
So what we're looking at, and you can see it on a SQT, but we're measuring buoyancy in a parcel of air, which is like a bubble of air at the surface and how it moves up through the atmosphere. So we're starting at this level of free convection, the LFC, and that's going to be the moment that this bubble of air that we are measuring is warmer than the atmosphere. And if it's warmer than the atmosphere around it, what does it do? What does warm air do? It rises.
Yeah, I know that.
So it rises on its own. Now, there's other ingredients that will help it rise, that will cause it to either rise quicker, slower. Now, as it rises, it lets off energy. The energy in the atmosphere is what we're measuring, and then that parcel of air, that bubble of air, will stop rising at the equilibrium level, which is, as it sounds, equilibrium level. It's the point where the bubble of air is the same temperature as the air around it, so it stops rising. So all of the energy that bubble of air has let off is CAPE.
Gotcha.
And that's what we're measuring for.
Gotcha. Now, you also have a different way for us visual learners here.
I've showed a SQT before, and it's a lot. I know you told me I have no idea what's going on with SQT. It's a lot. So what we're going to show is the map, and this is a model. So it's not exactly what could happen, but this is a rough estimate. This is using mathematical equations down the line.
Sure.
So this is going to show Friday evening, this upcoming Friday, we have those potential for storms. And part of the reason that we think there's going to be a potential for severe weather is the amount of CAPE in the atmosphere. So the blue, the yellow, that's less than 1,000 joules per kilogram. Joules per kilogram, obviously, is measurement of energy. 1,000 joules, not a ton, but you could get some thunderstorms.
Sure.
With that. But that orange to red, you're looking at 2,000 to 3,000 joules per kilogram, a lot stronger.
Yeah.
But where we're at, you can see the Joplin, okay? That's purple. That's over 4,000 joules per kilogram. So we're going to get some pretty strong storms if this is correct, if that continues to be the case, it continues to trend the same way, and we get 4,000 to 5,000 joules per kilogram. Those could be some pretty significant storms.
A lot of potential energy.
A lot of potential energy. Yes, you nailed it.
Absolutely. Thanks, Lindsey. That's another